is Arnie.
There was some beer.
Yeah.
You don't seem so.
So this is a presentation that
Big Grumpy.
that Arnie put together about binary add-ons and build system, as well as help from others.
And beer.
And beer, indeed. He removed there was a little grumpy ink on there somewhere before, but he obviously removed that somewhere. So the current state of binary add-ons is, we of course already have binary add-ons, and we have had since the Xbox. Screensavers, visualizations, and of course PBR clients. And they're either hosted in Tree or in some other large repository. And of course they're never updated in between releases, right? They only ever get updated during a core release, pretty much, anyway. And so we have this potential, but it's completely unrealized. Or, well, not completely unrealized, but mostly. And so the goal is to allow PVR add-ons to have their own release cycle, just like any other add-ons can. So rather than kind of being forced to only kind of get pushed out when we push out a release, which is hardly ever, it'll allow them to kind of update as they want. And we want this, of course, across the platforms, depending on where they are, and we want to be able to extend the concept to a bunch of other things, like our VFS, add-on audio codecs, and so on. Certainly the audio codecs has already been done by Spit. And so we basically want to get them out of the core source tree, but we still want to be able to build them when we build the tree. So we kind of want a bit of both. And the main challenge is that if we allow an add-on to have its own release cycle, it has to be built independently of XBMC. Okay, so that's the main thing. So we've got to have a separate build system for the add-on. And of course, in order to do that, you've got to build against an exposed API. So we need to get all the headers and so on all organised out of the build. So we could just deliver them all as zips, like we do on Windows and OS X and so on, because it makes sense to, right? Because you don't actually have a native packaging system there. But on platforms where we do have a native packaging system, or we want to use a packaging system that's there, then we want to take advantage of that. So we want to both be able to install using some, like apt, for instance, or use the system that we already have. So we need to be able to handle all of these things. So depends, bootstrapping, build core, install core and any data, and install the bindings for the add-ons. We need to be able to do all of that in order so that we can then, we've got the bindings then, so we can then build add-ons separately, and then of course, once we've done all that, we can then install them at runtime. So it's quite a bit of stuff is needed, and at the moment it's really hard to do all that because we've got this crazy system that has all, that's kind of 3 depend systems, 2 bootstrapping systems, 3 build systems, 3 installation targets, and some poor bugger that has to manually sync the add-ons. Okay, and when you commit something, make sure you don't accidentally change the hash for touched or whatever it is that screws in there. And so it's quite hard to kind of realise this because if you've got an add-on, you've got to make sure it works under all of these different systems. And of course, the reason is that these things aren't cross-platform, right? We can't just use Automate on Win32. Well, at least it's a bit tricky. So CMake is the answer. CMake, the C stands for cross-platform. And it can basically do everything that we need, in theory. And it can do it also without losing the tools that we already have, right? So if you're sitting on Win32, you don't want to lose the fact that you've got Visual Studio there. So we still want the Visual Studio project file. We still want the Xcode project files. But what we don't want to have is we don't want to have to whenever we add a file, which is just about all the time, we don't want to have to update those 3 things, right? We don't have to put it in a make file, get someone on, well, you can alter the Visual Studio project by hand. Just add the files in the appropriate place. But it's a bit trickier to do the Xcode project. So what we do lose if we go this way is we lose the ability to, in Visual Studio, click on your folder in your solution tree and add file. Same in Xcode. Instead of that, you'd add it to a text file. So essentially, you add it to the make file. Okay, and then CMake then builds the project file. So if you're on Win32, you'd add it to CMake. Next time CMake runs to generate the build system, your project file's updated. Visual Studio then updates the project. Same with Xcode, that's the same thing. So it can download, build, extract, depends, all that sort of stuff. It can generate our existing build systems and pretty much can do anything else. But the main disadvantage is the last one, is that most of us possibly haven't dealt with it before. So it's scary and new. So just going through how we currently have things and how we can maybe transform it to the new system. So currently we've got depends, so on some platforms, so like on Linux, right, you just get all your dependencies from the system. But on Win32 or OS X, we've got to grab the dependencies from somewhere else. So like we've got unified depends for Android and OS X, right, where we just pull down a bunch of tarballs, build them up, and so we've got the libraries for us. So the current system is kind of a bunch of help and make files, certainly it depends, or a bunch of pre-built zips on Win32, right? Pre-built libraries on Win32. And so we've got this kind of crazy system. And so we want to standardize this. So instead we can use CMake macros, which are basically just, let's just actually have a look at one. So this is the Win32 depends, which Swift's been putting together. So if we have a look at this guy. So this is the CMake file. Pretty straightforward. It has a project. That's a global identifier that's unique among the build system. So handles Win32 depends. It's got a bunch of functions. So these are essentially just helpers. This thing here, external project add, is just a way that's basically it's a CMake function that's designed specifically for grabbing grabbing a URL, which is for a library like TinyXML or something. It can pull it down, it can patch, it can build it with some other build system, not necessarily CMake. If it's a CMake build system, it'll build it straight away, but if it can do an AutoTools build system or whatever, if it's got a Visual Studio project, it can use that to build and so on. So these are just helper functions, add internal, add 7-zip. So this is for Win32, they're stored as 7-zip, some of them are stored as 7-zip files, so this is just, instead of the download command being take it from a Git repo, it says, so we're using the download command to actually extract the executable in that case. And this is the code, so if you have a look down here, these guys are the main blocks, so let's maybe look at the last one. So this stuff here handles everything in the download directory, so this is just a glob that just runs through, recurses through the download folder, pulls all the text files out, and ignores a couple. So ignores anything that's install.txt, and you'll see why in a moment. And then basically CMake's basically a string parser. So this thing, grab the file, read the file into a bunch of strings, pull out the file name component, pull out the path of the file name component. This replace thing is essentially take a bunch of strings and put them into a string list, and then pull out an ID and a URL. So if we have a look at what that code looks like, I should have done that in another. So it's going to, which one was I doing? Download. So these are all the folders for all the dependencies. So we just pick one, black. what's in here. And so you see there's an install.txt and the flat.txt. So inside the flat.txt, where you get it from. So it's just the name of the project, the ID of the project, and then the source. So it's just a pre-built thing on the mirrors. And then the install.txt just tells you something about it. So that's which file should I then pull out of that zip file for the install stage. So we just want to pull out the DLL and slap it into the PA player directory under system, and pull out the include headers and put them into the appropriate place, so that when we build core, it then has all the includes that it needs. So pulls out the ID, pulls out the URL, then if it's a 7-zip, add the 7-zip, otherwise if it, do certain things. And so that'll essentially just tell CMake to then go into that next folder and handle what happens next. So that's the basic idea. So you've got CMake or a download. So these are just two different systems. The downloads were just the pre-built binaries for Win32. The CMake folder, let's go and have a look at that. The CMake folder are ones that are built. So like taglib. Taglib is the library for, so we're pulling down the tarball of the sources, the source code, and it will automatically, taglib is already so those are flags that passes to the build system. So taglib already has a CMake build system, so that'll go straight away. Whereas like tinyxml, so tinyxml actually has a Win32 build system or a automake build system, but because it's like 4 files, Spiff just said, oh, what the hell, I'll just write a CMake make file for it. And a couple of other ones, so these other ones are, this one here's okay, so that's got a CMake already. And he's done one for Zilla. This is CMake. Here's the make file to build Zilla. Okay. So all of this can be done out of tree as well. So bootstrapping. So currently we have a bunch of different things for bootstrapping. Like one of the things is we don't want to include Java for all the Swig stuff for code gen. So we want to be able to run a bunch of bootstrapping in order to generate, the add-on API, for instance. And so there's a bunch of different things that we use for that. So there's a proposed system under CMake as well, and you can go and have a look at that later on if you wish. But basically CMake handles all of that as well. Building core, so we've got the 3 different techniques. So of course we just replace that with CMake. So we have a common CMake lists file for all the platforms, and then there's various architecture specific stuff. So some stuff doesn't build under, some stuff is Linux specific, so that's just all in a Linux subfolder. And of course you can use CMake external projects. So this is the FFmpeg one. So this is the stuff in order to build FFmpeg properly. Okay, so it's just calling the FFmpeg.
Is this cross-platform already, or is it just a proof of concept for running on MinGW or something?
So this here is straight from the. So it builds completely on Linux and FreeBSD currently.
Okay.
Everything, and it's not quite there yet for Win32.
So no cross-compiling yet.
No it hasn't got yeah.
Okay.
So that's to do. Yeah, and so essentially you can generate like the Visual Studio project and the Xcode project from that. So instead of adding a file to Xcode, you'd add a file to your CMake lists, and it'll automatically get done into the project file.
That's the most problematic thing in the first place for most of the developers, because they change projects.
Exactly.
You regenerate and you lose your changes.
Yeah, so the project file will no longer be in Git.
Right.
And then we've got installation of data, which is a bunch of different things. And some of the, I think, does the Xcode thing do, yeah, there's a packaging step, right, in the Xcode project?
What package?
The packaging step is a build target,
no,
right?
it's not in the Xcode project.
Oh, it's,
Right, for OS X it is.
Yeah.
For iOS it is not.
yeah. So we have these, you know, a mishmash of different things.
Special script or something.
Yeah. And so basically done in exactly the same way as the dependencies is done. There's another install data folder which basically just specifies exactly what you should install from the different things. So one of these things is it installs all the headers it needs that the add-ons are going to need. Okay, so it dumps all the headers for the add-on API so that you can then build the add-ons against those. And you can, of course, install everything else here. So this could include downloading Confluence from a different repository and building the skin and dumping it in the appropriate folder. Or downloading any of the other add-ons that we want to actually include with the release that we do. Which is already done for some stuff. So bindings. Again, we have a mishmash. And so the idea is that essentially we've got a generated, so list a bunch of stuff in lib/XBMC and include all the helpers that it needs, which is a bunch of scripts that Split's written.
Oh, you generate that one by using auto-tools?
Sorry?
You generate that one, it's a cmake.in file. Who is generating the .cmake file out of it? Looks like it gets...
Yeah, it's auto-generated, yeah, exactly. So it's generated by the CMake build system. So this is, yeah.
CMake can do it?
Yeah. Yeah, so there's a single text file that's used everywhere. So none of this kind of lots of different things all over the show. So now for building add-ons, there's some of them are actually CMake, and a bunch of them are batch files and make files and other things. And the idea is that, again, we can use CMake for all of them. So they could still have an AutoTools build system, but we could generate it from CMake, or just essentially call the build system from CMake. And there's a platform support library which is extracted from the PVR stuff. So all the stuff that add-ons might need to include. So actual installation. So within XBMC, so if you've got a zip file, we just do exactly what we always do. There's nothing special about that, just install the zip using the exact same code that we already have. On those systems that they have a native packaging system, then essentially the add-on installer is basically a plugin. So essentially so whenever you try and install an add-on that requires a native packages, such as apt, for instance, it basically just fires off, please install this to your apt plugin script, and then the script handles the installation. So the script would then call apt and pull down the appropriate packages and install them. And so Tobias has been working on that. There was some issue with login details, right?
Broken to Python.
Yeah, exactly. So, but there's a solution to that now. I don't think it's completely solved it yet. But yeah. So the only difference is that if you're using apt or something like that, some native packaging, then it's basically the installation is handled by script rather than by core. So as I said before, all of it's partially realised. So Bootstrap's working. Linux and FreeBSD, build, so does core, pretty much everything. Packaging is done on Debian and Ubuntu. The installer isn't quite done, but Tobias is working on it. Split's working on 132, and maybe are you helping out, or?
I started to work on the other stuff, but not on the details.
Right.
Because I wasn't...
You wasn't sure how it was all going to fit together, maybe?
Yeah, because I don't see if you gain anything on it. At least
if you
don't compile it around, you just download it. I don't...
Well, if it's pre-compiled,
right,
then essentially it's just a different system than the batch files.
exactly. That was
Yep.
the point. So But I only saw this proof of concept a few days ago. So
Yeah.
I didn't really test it well.
Yep. Yeah, so it's just another way to do what we're currently doing,
For the
pretty
other
much.
stuff is fully okay.
Yeah, yeah. And I don't know what these drop durs are, but there's a Smith has a bunch of stuff on Atlantis, I think. I don't know what they are, but anyway, I didn't get the chance to ask them about it. So, and it also actually speeds up the build system. So these are timings on Spiff's awesome laptop. And it's actually, these are conservative because currently there's some extra unnecessary stuff in some of the auto tools projects that CMake generates. There's a bunch of stuff that we do that's not actually necessary because we don't actually go on to use it. So the times are conservative, but there's about a 15% speed up, which is a bonus. So a bunch of stuff is already in mainline. So you'll see the CMake, there'll be a CMake folder under the projects folder. So that's already, some of the stuff's already there. The add-ons are available, and the main branch is the CMake build system branch on Arnie's GitHub. So basically, we need volunteers to help out, basically. So essentially, we need unified depends solved, or something working for Android, basically. OS X, and iOS, and Win32. So essentially, all that Spiff's wanting is some help and some enthusiasm, and maybe we'll get this thing in. Any questions? With the caveat that I probably can't answer them.
The current unified depends, or the uni depends.
Yeah.
You plan to replace them with CMake 2?
Yeah. So essentially, we'll still be calling the auto tools. It'll be building them in pretty much the same way, right? Because at the moment, it's just like we have a make file that essentially fetches the tarball, patches it as we need it, and then calls the build, right? It's exactly the same thing. It'll just be written in CMake.
Well, I worked for a couple of years ago. I worked for a couple of years with CMake build systems, but not cross-platform, not cross-compiling stuff.
Right.
I'm not sure how the status on CMake is supporting cross-compilation, but I guess they are up to the task.
Cross-compilation is working really well.
Yeah? Volunteer found.
The company I worked, they did the cross-compilation for cameras.
Okay. But how does it integrate into OS X environment? Because it's a special sort of cross-compiling with the framework stuff, but I guess it's also important. I thought I remember that. But it's really huge effort on the macOS, iOS, and Android stuff. Because it's the biggest part of the build system currently at the beginning.
Yeah.
Well, I can have a look for it.
Do we really need it for the binary stuff? The change for the depends. Before we Swift started with proof of concept, we just worked on the binary add-ons where we have CMake rules for building just downloading the depends and build the add-on. So my question is if you can just implement that and maybe later or whatever, you take care of the depends.
Any reason? Because
Effort. Because at the moment I really don't think to switch, because my first plan was rather to use this one guy at the forum posted about this NuGet server. Maybe to use that rather than that. So I'm not sure yet.
this would be an alternative that works on every platform. NuGet doesn't, as far as I know. Yeah, so.
Yeah, for sure, but on this we have also to adapt.
Yeah, but
it will work on every platform.
the goal eventually is to move Win32 to the same unified system. In the
future.
Exactly. So for now, we'll get it working.
Yeah.
Right?
Of course, but then we need more help.
Sure. Yeah.
Well, do you really think if we are done with doing depends based on CMake on Windows, we gain a we have nothing working on macOS. Nothing. It's not done automatically.
No.
Because he's still putting binaries for Windows.
Yeah.
And placing it in the right directories. And on the unified depend system like it's now, it's a completely different thing. Almost even more complex.
Yeah.
Yeah.
So, yeah, we need to.
There's not many Windows and OS X devs around.
We have a lot of OS X, no?
Yeah, I mean, a lot of Macs here, but.
Yeah.
Yeah.
So
I
anyway,
guess it works for Mac or Android, but work for both. Because those are the two or three platforms using depends. That choose depends. So we don't read them. Not even Mac.
Sorry, unified depends as OS X, iOS, and Android.
Yeah.
I'm making even Raspberry Pi.
Yeah.
Comics is working on that too.
Okay, yeah.
Yeah, I have just a bad feeling a bit because unified depends are really working quite well at the moment, and it's
Sure.
already easy to add something to the depend system to throw all the effort of Cory away now, and it was really big block of work he did, I guess. And he had to fight against Scott and everything, and now he just know to do CMake now.
No, but I think what he did was not lost because he still unified it.
Yeah, yeah.
No, we just replaced the make files by CMake files. The concept is still the same.
But there's really no reason to start with that.
You can just call the make file.
Yeah.
Yeah, yeah.
I mean,
Yeah, absolutely. The first iteration might just be call all this. Yeah, call it. Run this make file. We don't have to, go to one extreme. Just like with Win32, right? We could just say call this batch file if we wanted to.
I mean, we could try to generate the projects. Aside from the depend stuff, the projects for Visual Studio and Xcode, we could try to generate them from CMake and have one common CMake list.txt.
Exactly.
That
Yeah.
would be
Which would be
the
huge.
benefit of if someone wants to add a file to a project, he just adds it once to the CMake list.
Yeah.
Exactly.
That would be
We
a part of the project.
We don't
I mean, the first
things
step-
like we had something in 32 forget about Mac.
Yeah.
Exactly. And everyone can edit it.
But we don't need it for the defense because I don't want to change any of what's
Right. Yeah, I have a bit of the same feeling at the moment because it works quite well.
No, that's...
Yeah. Well, I think we can. I think we can do it piecemeal. I think we can say, look, if we want the depend stage to just be run make in this folder, essentially, right? Yeah, done.
I mean, the thing is, you build XBMC with CMake, so you have your root CMake list, and then everything starts with CMake. Then you run the defense stuff, the existing one, and if you add new stuff, then you have already CMake, and you obviously would use that for parts, and if there's time, replace the other stuff.
I kind of like the idea of doing it for the core of XMC, replacing the make files, the CMake list.txt, getting rid of the config maybe.
Yeah.
And the add-ons and all depends of the add-ons.
Yeah.
Not depends from XBMC, but
It depends on the add-ons.
Yeah.
That stuff that would really help.
Yeah, because
Absolutely.
Swift already did all the
Yeah.
binary stuff with CMake list. There's already something.
Yeah.
working.
Yeah.
I would
So-
agree with that.
So, like, if whoever wants to look at unified depends, just email Spiff, catch them on IRC.
Right.
So what about Linux distribution of that package XBMC? Are they expected to package the binary add-ons as well, or?
But it would be, well, I guess it's up to the platform, I suppose.
Okay, yeah. I'm a developer of Mageia Linux distribution, so I'd prefer if XBMC hosted just chips and handled it just like any other add-on.
Right.
So there is no real need for administrative privileges and so on. So is it possible that XBMC hosts these add-ons then binary add-ons for yeah.
I would imagine you need your own repo then. We can't be hosting dev.devs and everything like that. So, I mean, it's easy enough to make your own repo. It's like one XML file, throw it on HTTP.
What do you mean, like our servers when it holds it?
No, like use your own servers.
Not XBMC servers?
Right.
Why?
Why would we host Debian's? Debian wouldn't want us hosting their .devs.
Oh,
It's
okay.
not our responsibility to, do that.
So how many add-ons are we expecting? Because
As many as you want. I mean, it's your packaging, right? So I mean, it's what your users want, I guess. I'm assuming that if you don't package something, one of your users will eventually be like, I want this bad enough to do it, and then become a maintainer for it. So it'll be like a separate package under your system. It's gonna be a pain in the ass.
yeah, because I maintain PDR add-ons, and there's a lot of them, and even if it's most built the same way, it's a lot of work to update them, keep them up to date, and we are really short of manpower. So
Okay,
I mean,
put the ones you like in first. Put the ones that you want in first. Somebody asks you like, no, maybe I'll do a couple of them. And then start slacking. Somebody will be like, oh, you need some help with this. Pull some monkey on.
yeah. It's yeah. Because if you put it on our repo, then the user needs administrative privileges to install.
So do you have, well, can you give them, or what do you guys use in terms of,
Sorry?
what do you use anything for like policy kit or whatever it is nowadays?
Sorry,
Do you have any policy services?
Yeah, that kind of stuff could be used, I guess. So.
Yeah.
So you're giving everyone the ability to install some specific packages. So how does it work exactly? Do you check user and the administrative privileges?
Well, for Ubuntu, there's this Python package called Add-Ons. It lets you interface with all of that.
Yeah. Okay, that's.
We can talk about that.
Yeah.
Yeah, but I mean, so the idea would be that the packages would handle the packaging. Yeah.
Ideally, that's what they want.
Yeah.
Because like Debian Labs wants to build their stuff. They're going to do all their crazy handle security stuff on it.
Right.
There is I brought the example before. Firefox also, for example, Firefox provides also binary add-ons. Some of Firefox add-ons contain binary stuff, and they just use a one central repository for all use. And
How do they, so they keep whatever your build system is? I mean, we'd have to maintain your entire
The packaging steps, right? Yeah.
sorry.
We'd have to have your entire current libraries and headers and stuff. You have to have an entire build system for it. Because we need, we have to have the API compatible with all your libraries that you're shipping.
Yeah. If you want to use certain libraries, then you have to profile.
We can definitely
Yeah.
yeah.
Yeah. Any other questions?
Any timeline?
Sorry?
A timeline? Is it stuff for 14 already? Or?
Well, I think it's required for retro player, yeah?
Is it?
Well, it's definitely required for binary add-ons.
Yeah.
Yeah.
I mean, you've got emulators there, right?
So it's going to be 14 or 15. Probably. 14.
Yep. Okay, so,
This point, breakout, so.
Hours ago.
sorry?
Working